In the vast darkness between the stars, Voyager 1 travels onward, our silent emissary to the cosmos. Launched nearly half a century ago, it's the farthest human-made object from Earth. Voyager 1's mission to explore the unknown, to send back whispers from the edge of our solar system. These whispers have transformed our understanding of the universe, revealing new worlds and the true nature of the space between stars. More than a probe, Voyager 1 is a symbol of human curiosity and ingenuity. It took advantage of a rare planetary alignment, visiting Jupiter and Saturn, capturing breathtaking images and invaluable data. Propelled by gravity, it became the first human-made object to enter interstellar space. But the journey hasn't been easy. Its systems, powered by decaying plutonium, are fading. In late 2023, Voyager 1 fell silent. A sudden communication blackout left Earth in the dark. The faint signal from 15 billion miles away had stopped, reminding us of the mission's fragility. Engineers raced to diagnose the problem, knowing each transmission could be the last. Voyager's story is one of human determination against the vastness of space. Its images of Jupiter's storms and Saturn's rings are now iconic, inspiring generations. Voyager 1 pushes us to ask, what else is out there? Are we alone? Even as its voice fades, its journey continues to inspire. The mission's global impact is immense, reminding us we're part of something far greater. Voyager's legacy is not just in data, but in the questions it leaves us to ponder. Its journey is our journey, an enduring call to explore. As long as it travels, a part of humanity travels with it. Voyager 1's odyssey is far from over. Voyager 1's story began in 1977, an era of bold ambition in space exploration. NASA launched two identical spacecraft, Voyager 1 and 2, to explore the outer planets. Voyager 1's faster path let it reach Jupiter and Saturn first, transforming distant points of light into dynamic worlds. At Jupiter, it revealed the Great Red Spot, discovered faint rings, and found Io's volcanic activity. At Saturn, it captured mesmerizing images of the rings and discovered new moons. A close flyby of Titan revealed a thick, nitrogen-rich atmosphere, but sent Voyager 1 out of the planetary plane, ending its tour of the planets. With its primary mission complete, Voyager 1 set course for interstellar space. For decades, it traveled through the Sun's protective bubble, sending back data about its structure. In 2012, it crossed the boundary, becoming humanity's first interstellar messenger. Now, it samples the interstellar medium, measuring cosmic rays and plasma from beyond our solar system. Voyager 1 is a lonely sentinel, exploring the vast cosmic wilderness. Its journey redefined our place in the universe, and it continues farther than any machine before it. For years, Voyager 1 sent back data from interstellar space, until, in late 2023, its transmissions turned to gibberish. The spacecraft's signal was strong, but the data was a meaningless repeating pattern. The culprit, a malfunction in the Flight Data Subsystem, or FDS, the probe's brain for packaging and sending information. Diagnosing the problem from billions of miles away was daunting. The FDS was corrupting data before transmission, leaving engineers with no clear diagnostics. Voyager's vintage 1970s hardware had survived decades in space, but time was catching up. Power was dwindling, and each new issue was a reminder of the mission's fragility. This glitch was the most serious yet. Without a functioning FDS, the mission was effectively over. The silence was felt deeply by the team and the public. Voyager is our eyes and ears in the interstellar void. Yet the engineers at JPL refused to give up. They began a painstaking process of troubleshooting, sending commands that took nearly a day to reach the probe, and another day for a reply. Patience and precision were their only tools. The fate of humanity's most distant outpost hung in the balance. The challenge, restore Voyager's voice, or lose our connection to the stars. The race to save Voyager 1 had begun. Fixing a spacecraft 15 billion miles away is unlike any challenge on Earth. Every command takes 22 hours to reach Voyager 1, and another 22 hours for a response, a 45-hour round trip. Each step had to be meticulously planned. There was no room for trial and error. The team's first move: send a poke command to prompt the FDS to send different data sequences. For months, the data remained garbled. The FDS was stuck in a loop. Engineers relied on decades-old documents and their deep knowledge of 1970s systems. They simulated the FDS on the ground, thinking like the original designers. The breakthrough came in March 2024. A command requested a full memory readout. The returned signal, though still unreadable, showed variations that pointed to a specific memory failure. The team confirmed a section of the FDS memory had failed. The puzzle was finally coming together. Now, they had to find a way to work around the damaged memory, remotely, with no margin for error. The next step would require creativity and precision. Voyager's fate depended on a software solution to a hardware problem. The mission's survival was in the hands of engineers, and time was running out. The team pinpointed the problem, a single faulty chip in the FDS memory, just 3% of the total, but critical. The corrupted section held the software for packaging and transmitting data. Without it, Voyager's voice was broken. The cause? Possibly aging, or a cosmic ray strike. Interstellar space is harsh. The challenge? Fix a hardware failure from billions of miles away. Redundant systems couldn't help. The backup FDS was inaccessible. The only option? Rewrite the software to bypass the damaged memory. The engineers devised a plan. Move the affected code to healthy memory blocks. But the FDS memory is tiny, with no single empty space large enough. The code had to be split into smaller pieces, carefully fitted into scattered gaps. It was like performing remote brain surgery on a 47-year-old computer. The operation would be delicate, complex, and unprecedented. Success would mean restoring Voyager's voice from the void. The plan was bold. Dissect the software, move it into scattered memory gaps, and rewire the FDS to find it. Each code fragment had to fit perfectly, like sentences rewritten in the margins of a book. The team tested the patch on Earth, simulating every step. A single error could crash the FDS forever. On April 18, 2024, they sent the first part of the patch to Voyager 1. 45 hours later, the signal returned. For the first time in 5 months, the data was clear and readable. Voyager 1 was sending back engineering data, its health and status restored. The first step of the remote surgery was a success. The whisper from the void had returned. Humanity's farthest explorer was alive again. Restoring engineering data was a triumph, but the mission wasn't over. The next challenge: restore the flow of scientific data from Voyager's instruments. The team prepared more commands, moving and relinking the remaining code. Each update required a 45-hour wait, slow but necessary for stability. The goal: bring Voyager 1 fully back online, resuming its unique observations of the interstellar medium. Its instruments measure cosmic rays, magnetic fields, and plasma waves, data no other probe can collect. Restoring this capability is vital for science. The recovery is a testament to human ingenuity and the robust design of Voyager. Built in the 1970s, it has survived nearly half a century in deep space. As it continues its journey, Voyager carries our hopes and ambitions. Its voice, once lost, now whispers to us again from the stars. The mission endures, and so does our curiosity. Voyager's story is far from finished. Voyager 1's legacy is etched in history. Its images of Jupiter and Saturn inspired generations and transformed distant worlds into real places. The discoveries of Voyager 1 and 2 laid the foundation for modern planetary science. Beyond science, Voyager carries the golden record, a message in a bottle for the cosmos. This gold-plated disc holds greetings, music, and images from Earth, a symbol of our hope to connect with others. Voyager will drift through the Milky Way for billions of years, a time capsule from the 20th century. It's a monument to our curiosity and desire to explore. The mission bridges generations, designed by one, saved by another. Voyager is more than a machine. It's a project that connects our past, present, and future. Its journey is a testament to what humanity can achieve. Voyager 1's future is finite. Its power source fades each year. Engineers have shut down systems to keep it alive, but by the late 2020s, its science instruments will fall silent. Even after, the team hopes to maintain a simple signal, tracking Voyager's journey as it drifts farther away. By 2036, the transmitter will likely go dark, ending humanity's direct link to interstellar space. The end will be quiet, a slow fading rather than a sudden loss. Voyager's silence will mark the end of an era, but not the end of its journey. The probe will travel the galaxy for eons, a silent relic of a distant civilization. It will outlast us all, a testament to our ambition and dreams. Voyager's legacy is not just in the data, but in the inspiration it provides. It urges us to keep exploring, to keep reaching for the stars. The final transmission may be inevitable, but Voyager's journey will never truly end. As long as it drifts among the stars, a part of humanity goes with it. The Odyssey continues. Our last goodbye, but not the end.